Welcome and thank you for joining us for BlueLock's webinar, How to Budget for Cloud-Based Disaster Recovery. I'm Alicia Gaba, and I'll be your moderator for this session. Our presenter today is BlueLock's Chief Technology Officer, Pat O'Day. As a quick housekeeping, I will go ahead and cover some basics. First off, feel free to submit your questions throughout the session using the chat function in the WebEx panel, and we'll make sure to tackle those towards the end of the session. We also encourage you to tweet about the session using the hashtag BLRAS. And we'll also make sure that you receive a copy of the webinar slides and recording within the next few business days. And we're also giving away an iPad mini, so make sure to stay till the very end. Pat, can you move to the agenda slide? All right, awesome. So this webinar will last just 1 hour, and during the session, Pat will discuss how our customers are creating successful DR plans today and different ways you can approach integrating cloud-based DR into your strategy and budget. He'll also share detailed information to help you identify how much your use case might cost per month. And as we close off the session, as I said before, we'll draw the iPad mini winner from the remaining attendees. And with that, I'll go ahead and hand it off to Pat O'Day to get started.
Great, thanks, Alicia. Hey, everybody. Oh, there's the mini graphic that pops up and surprises me. To work through the material, what I first wanted to start with was a look back at 2013. I know it's not over yet, but it feels like it's almost Christmas already, at least according to what I see in the local retail stores. But anyway, just touch base on how we got to where we are and why cloud-based disaster recovery appears to be emerging as a pretty significant trend, certainly for planning and moving ahead in 2014. So Gartner calls this the nexus of forces, and what they mean by that is sometimes it doesn't take one change to make something happen. It's actually convergence of a number of things all occurring around the same time or in the right order to sort of make a new phenomenon or a paradigm change occur. And one of the key ones there is that cloud has moved over the last 5 to 7 years from a very young new technology that was probably significantly overhyped early to something that the majority of companies out there today, at least that we talk to, are using in production in one way, shape, or form. So the amount of comfort, confidence, and understanding of what use cases are good for cloud and which ones might not be so good is really stronger than ever. The other thing that's occurring, and I used to think that this was just me being a little nervous every time I watched CNN, that 9 of the stories were about a disaster or some terrible incident somewhere, with the occasional story about twerking thrown in apparently for comic relief. But we look back at the statistics, at least from a FEMA perspective, and if you fast forward from 1953 to last year, you can see that the number of actual declared disasters has gone up quite significantly from around 20 or so to well over 100, and with actually, I think that's just the drop off in the spreadsheet, but almost 250 in 2010, 2011. And that's pretty significant. Part of me believes that's just because people live in a lot more areas than they used to, so things that were happening sort of out in the mountains or the woods or out in the ocean are now affecting people because they live there and have businesses are there where they weren't before. But the other factor is that the impact of a disaster on a business's ability to operate, particularly from a technology standpoint, is much greater. If you think about 30, 40 years ago, when there wasn't necessarily the concept of this central data center and networks and computers everywhere, the idea that a sales force could keep selling or could keep sort of on the road and keep going because it's people moving around the country physically, the idea that the home office might be disrupted a little bit probably was less significant to the company's ability to move forward. But if that takes out all the underlying systems that the manufacturing network or logistics network or the sales force used to operate, and they're essentially crippled, or it impacts travel, then you have a real problem. And those are more modern issues that we're dealing with today. The third thing, this is the one that I'm, as a CTO, that I get the most excited about, is the technology has really stepped up to embrace cloud. So we do a lot of other sessions on how our technology works and how replication in the cloud works in general that I would encourage you to attend, that get into each of these in a little bit more detail. But just know that with virtualization and cloud-based technology, particularly being the keys, that the barrier to entry to subscribe to a cloud-based disaster recovery service is lower than ever. You can literally upload one application or one VM, oftentimes without disrupting it from a production standpoint, and get it protected. The quality is a lot better too, because instead of sort of showing up at a recovery site with a tape in hand and hoping that the backup is good, hoping the right equipment's available at the other site, because so much of this is being done through software, you're essentially powering up a recent snapshot of your entire application environment. You're not trying to put Humpty Dumpty back together again using completely different parts after you got off of an airplane. So your odds of success are much better. That same software-powered recovery is what makes testing and ease of use significantly different than it was before. A lot of our users will actually simulate a full recovery in less than a few hours. And they do it in the sandbox. They basically just hit the play button. The entire environment comes back online. They log in, kick the tires, make sure the data is good and the application works, and then they're done. And again, we've heard companies spend weeks, if not months, getting ready for the biannual recovery test. So it's a significant drain on resources. Technology compatibility, we could call that SAN agnostic here, because that's usually historically what you've had to have if you were using not tape-based recovery, but actually protecting your SAN with another SAN somewhere else, or your storage with identical storage somewhere else. Software abstracts all that, so you can have it be an EMC shop or a NetApp shop, or whatever your vendor of choice is at your location, but you can use a cloud provider and whatever storage they choose on the other side, and you're not worried about having identical systems and identical versions in both places. And there's some application awareness now. It can get better. I'm very confident that that will improve, but the idea that you can boot up systems in a certain order so that they work correctly, for example, bringing Active Directory up before the database server is very important when you recover a Microsoft-based application. Things like that. You can actually code the boot order and priority of machines and all the different things like that to improve the overall recovery quality. And those are things that either would trip you up and you'd have to recover again, or that was something that you would end up performing manual, and it would just delay the amount of time it would take to recover your environment. So if we get a little more specific in what we think those disasters are, we actually were curious, so we went out and pulled together data. This is a pretty diverse list here in terms of the types of incidents and the cities. But if you look across this environment, you can see that the types of issues you might be dealing with based on the area that you're in or an area that you might be close with, and in particular the time of year that those things are likely to happen, which isn't reflected well in this chart. But I think if you're in that market, you have a common understanding of what happens when. You can see the level of diversity here, and I highlighted a few on there. You know, the amount of floods in New York City, the amount of hail damage that Minneapolis gets because they're a little further north, so the same rainstorm that might be rain in New York actually comes down as hail or ice in Minneapolis. Both those incidents can destroy a data center or cause prolonged downtime for power or the data center itself for a long period of time. The counterpoint is, you look at like Baton Rouge down in Louisiana, they certainly don't have the amount of ice-related issues that there are for those folks up north. But the time of year is also different, right? So it's just a really diverse factor here. But when you're looking at planning, it's really important to understand what the highest likelihood of risk is for the environment where your applications are, especially those of you that run work in IT or in national companies and might have more than one data center. You might be operating a DR scenario kind of all year long, and it just sort of higher and lower priority depending on the city that you're talking about. One important note is this chart, actually, the data really helped guide us to setting up one of our data centers in Las Vegas, because the majority of our, we're actually headquartered in Indy, and the majority of our customers are from around the country and have all these things related to flood, hail, and high winds and ice storms. But Vegas has almost none of those, or none of those at any level of significance. So if you're in one of those markets, it's nice to be able to replicate out to the middle of the desert for your DR site, because the odds that the same tornado or hurricane that affects you will affect Vegas are pretty low. Oh, and of course, there is the threat of the zombie apocalypse, which based on all the data we have, is a pretty equal opportunity employer. So it's good to just have a second place, regardless of where it is, to buy you time after an outbreak. So one of the things that's interesting is you look at that data and it kind of indicates that it should be pretty obvious everybody should have, nice, modern, efficient protection, and why aren't you working on this now? So one of the things that we look at is, when we talk to someone is, why isn't this happening? Why aren't you doing it today? And what we hear back is that it's not a priority. That usually means that the conversation between IT and the business isn't as healthy as it is. Or sometimes it means that people are moving forward and trying to address every application in the environment with one plan. And the business is saying, well, it's really only these two apps that everybody cares about. And IT and the business sort of get in an argument over what the right thing is to do there. So sometimes, breaking it down from how to eat an elephant, one bite at a time, so to speak. That's probably not a good analog anymore, but the point is, dice it down into manageable chunks, and you might be able to make more progress. We hear that it's too expensive. Hopefully the message you're getting here is that the way cloud-based recovery works, where you only pay for what you need when you need it, helps address the expensive aspect a little bit better. Connecting to the cloud is complex. There are a lot of ways to do that, depending on your level of security and bandwidth and replication you need. Latency is something that we run into a lot, where you might have a company whose headquarters are in New York and the data's in New York, but their backup site is somewhere out in California, and the experience that the users have during a test accessing applications in California that used to be in New York, all the latency that's been introduced slows everything down. So those things are not, those are very real. Cloud is still scary, so despite my wonderful statistics slide earlier, you still don't believe it. There's a lot of reason to question that, but again, I think it's important in establishing what the requirements are. I call it clicking down. So click on that word scary and get somebody to define what that is, 5 things they mean, and then tackle those in detail with your team or with your provider. And then we're hearing with people that sometimes they don't have the skill set, or maybe there are other skill sets they'd rather develop more strongly, like software development, than managing the DR itself. And this is a part where working with a service really might help you open up what skills you need to have versus which ones you can rely on a vendor for. A little bit about BlueLock, just to give you the context of how we're going to set up the budgeting conversation. We host what are called virtual data centers. We have 3 different kinds. A virtual data center is just a large pool. You can almost think of it like a giant server. It's a massive pool of memory, CPU, storage, and network capacity that you can load as many applications in as you want. We have some people load one application in the environment, and those virtual data centers are really small, and we have other people put 30 or 40 applications in a virtual data center. We have 3 different kinds. We've got a 5 series, which is all about uptime and security. Its job is really just to run production applications. We have a 2 series virtual data center, which is more about quick access to resources and low price. So if you need 30 machines over a weekend, for some testing, you fire them up, run your testing, turn them off on Monday morning, and you only pay for what you use. So it's kind of classic cloud, so to speak. And then the 4 Series Virtual Data Center, which is really the centerpiece of the environment today, is primarily a storage target on a day-to-day basis. So if you're trying to protect, let's say, 5 terabytes worth of data or 50 terabytes worth of data in your environment, you would store all that data in a 4 Series Virtual Data Center at BlueLock in the cloud. And then when you actually went to test the applications or declare a disaster, all the compute memory, network capacity, human resources, everything else is added. Almost, if you think about freeze-dried food and rehydrating freeze-dried food, we add all the other stuff in, but only when you need it. That's what keeps the cost low. So in terms of recovery as a service, what we're seeing are 2 models. So again, just like sort of understanding the sensitivity of the location you're in, the types of disasters you might or might not experience, it's also important to understand the type of recovery that you might need. The primary use cases that we run into are what we call TwoCloud Recovery and in-cloud recovery. So if you look at TwoCloud Recovery, what that means is that you've got your data center here, and it could be a co-location facility, but it's anyway, it's wherever your stuff is, and you're using a BlueLock 4 Series Virtual Data Center as your backup site remotely, just the way that I described. And just to show you the whole picture, we've got a couple 2 Series VDCs and 5 Series VDCs out there as well, because you can do all those. In-cloud recovery as a service is where you might already have a BlueLock 5 Series VDC that you're hosting an application in the cloud, say at one BlueLock location in Indianapolis, but you want to protect it in case anything goes wrong in Indy, like an ice storm. And so you use a 4 Series Virtual Data Center out in another location in our Las Vegas location. So those 2 sit there and replicate, and off you go. Our belief is that the majority of you are probably thinking more about TwoCloud, where you're running your own data center in your own environment, and you're looking at the cloud as a way to basically give you a second data center just for backup. So what's your approach? This is a really good question and a really good thing to think about. And we're running into 3 different ways that we see people approach this. We're looking at really a walk before you run, where someone doesn't necessarily have a lot of cloud experience, maybe has cloud experience but not DR experience, or maybe vice versa. And they're looking at how do I get started? I just want to learn this. I want to make sure it's going to work. I want to kick the tires. I want to understand the cost, all that stuff. Typically what we see people there do is they take one specific application and they decide to protect it. And it's typically one that doesn't have good protection today. So any improvement or any additional protection is a positive improvement. We're also seeing people go in and classify a set of applications, usually described in tiers 1, 2, and 3, in terms of what's critical to the business, what's important, and what's really kind of ancillary or tertiary, and you don't really care if it comes back or not, or if it comes back, it's really more of a convenience than anything. So they'll pick anything that's in that tier 1, classified as a mission critical application, and they'll set a policy that all that gets protected by the cloud. It's typically after they've tried it with a different application that they move more toward a policy like that. And then we are running into some companies that are under a lot of incentive or pressure to save cost, or their DR plan is so bad that not the plan isn't bad, but the actual implementation and the success rate are pretty low, that they're trying to set this up as a strategy and just throwing away the old and starting with a brand new plan to use cloud for everything. And that may be too aggressive for a lot of you, but we are seeing some companies do that in certain situations. So as examples, Tire Discounters is headquartered in Cincinnati, Ohio, and they are a retail company. They have around 40 stores, I think, around the country. They sell tires and tire-related products through. But they also have a headquarters data center where they run ERP and inventory systems that are all connected to all of the stores. So what they chose to do was basically the getting started model, where they picked critical application, again, the ERP and inventory. They're sort of classified as the most important single apps in the entire environment, and all the stores depended on that. They used a combination of a BlueLock virtual data center hosted in our Indy location, and they leveraged the TW Telecom network product, which is called E-Link, which is something you should think about if you're budget concerned, because it sort of does to networking what cloud did to infrastructure. You only pay for exactly what you use, which is perfect for replicating your data from your environment to the cloud. Anyway, we talk a lot more about that in other sessions if you have an interest there. The key is that during normal operation, they basically are replicating the data back and forth over the TWE-Link connection. You could also use the internet of VPN. They both work. And then when they fail over, they chose to not only move the production applications to the BlueLock VDC, but they also are reconnecting all the wide area network that all the stores use so that they can access the systems in the BlueLock VDC as well. So it's basically an application cutover and a network cutover all occur at the same time. Ursinus College is an example of where they basically set a tier 1 policy. They have a lot of, they almost operate, in my understanding, like a software as a service company, like eBay or Salesforce, to the students and the teachers at the college. And what I mean by that is a lot of the online education, the learning, the enrollment systems, all these applications that were at one point sort of back office applications or didn't exist are now internet-facing applications and are treated as seriously, if not more seriously, than most internet-facing properties that we're used to out there in the traditional world, you know, Twitter, et cetera. So their uptime requirement and their disaster sensitivity went through the roof for this particular set of tier 1 applications. So they put in place a policy that basically anything that meets these criteria in terms of being externally facing and mission critical for the student body or the teachers or for teaching are now considered tier 1, and those are all replicated into the cloud environment. For eMeter, this is another scenario. They're actually a Siemens business unit. They had a similar policy-based thing where they are a SaaS business unit. They actually monitor the utility meters that go on the back of houses, the ones that have been converted to talk to cell towers and not the person with the clipboard that walks through your backyard every once in a while. So that SaaS application receives all that data. They already, because that application was really important to their business unit, treated uptime very seriously. What had happened when they were acquired by Siemens is that they fell into a large company way of thinking, and DR was sort of normal table stakes for a large business like Siemens. eMeter was classified as a critical application in that regard. So again, from a policy standpoint, they had to add a lot of additional data protection. So they are now replicating all the applications that they run in production from their location in California to a BlueLock VDC in Vegas. So hopefully you've seen where there's all those different approaches in terms of how you would start out the conversation and the level of risk and also the level of importance of getting additional protection are based on your specific requirements. So now let's dive a little bit into dollars and details. These are numbers that we put together based on having helped existing companies, but also we did some survey data for the analyst community. They gave us a bunch of different scenarios. So we tried to sort of bring those together and give you the best thing we could from if you just took a stab at it, you know, kind of wet your finger and stuck it in there to see which direction the wind was blowing from a budget standpoint and give you something to work with. Obviously, the situation varies, the mileage varies based on your scenario, and we're happy to work with you on that. So probably the key thing, before you even look at how much a DR solution costs, is to look at the impact of an application going down to the business itself. Because if you're in the technology sector, you put together this great proposal, you've got this great plan, and you come up with this, $1 million DR option, and you come back and they say, well, that application, it could be down for 2 days and we might lose $10,000. And you're like, well, yeah, but what about the marketing value and embarrassment, and, all these other factors, right? It's usually better to start the other way and try and understand from the business what the impact of those applications can be. And again, if you look at the getting started model, You don't have to look at all the applications or a really big giant one that you think everybody's worried about. Just ask the business, what's the one app that if it suddenly went away for more than an hour, more than a few hours, more than a day, that everybody, sort of the world would stop, everybody would take notice and be called out on the carpet. What is the likelihood of that application being disrupted? So again, if that application is hosted out in a data center in Las Vegas, then I think if you're in a good data center, other than the Hoover Dam potentially having an incident, the likelihood is fairly low. But if you're in the Southeast, in the Panhandle, on the East Coast, or on the far West Coast, the odds of there being some kind of a storm-based, Mother Nature-based incident are a lot higher. If you're here in the Midwest, our biggest concern, there are tornadoes, those do happen, but most of our data centers are set up to be pretty well protected against those. But the thing we worried about is not necessarily the tornado, but something like a power disruption caused by Mother Nature that might go on for a prolonged period of time. So again, what's the likelihood? And what's the sensitivity? Is that application a problem if it's down for an hour, or does it really take a day before anybody notices? And that really establishes some form of value for what the protection for that application would be worth to you. The next thing is let's say something did occur. What recovery time, how fast, RTO is the acronym that we use there, recovery time objective. How fast does that application have to be back and serving users or processing transactions? If it's something that, needs to be back in 5 minutes, then DR is probably not the right option. It probably makes sense to actually architect the application. One of our customers is F5 Networks, their Dev Central website. They actually, as you can expect, as being experts in application availability themselves, they've architected Dev Central to run in near simultaneous mode between two BlueLock virtual data centers in Indy and Vegas. So if there's a slight disruption in one, within seconds they're running out of the other location. But that was their requirement. They take uptime extremely seriously for that application and for their reputation. But if it's something more like 2 or 4 hours, then real-time replication, like recovery as a service into the cloud, makes a lot of sense because that's a normal recovery time in that kind of environment. If it's 3 or 4 days, then maybe having a tape backup that you store out at SunGuard, or not SunGuard, Iron Mountain, it could be SunGuard, I guess, but having a tape backup that you store somewhere that you can go get back eventually, and having an arrangement with someone, maybe in an office building or a warehouse that you can ship a whole bunch of equipment from Dell from, that might be okay too. But the key is know based on that one application you're able to identify, get the business to tell you how long it being down would be a problem for real. And then RPO is the other key factor. How fresh does the data need to be? We see people try to recover e-commerce applications using a tape backup that was usually run at midnight the night before, and they lose almost a whole day's worth of revenue and transactions when they do that. Fortunately, the solutions that work in the cloud, like the ones we're talking about, you can get the RPO down to minutes and lose very little data. But again, knowing what that number is and not trying to take a stab at it means you're not going to underserve or overserve your particular environment. So this is, we talk about the cloud. This is kind of the same thing where, depending on what your approach is, we hear a lot of people that will provision infrastructure in their DR environment using 5-year-old equipment that they've depreciated out of their production data center. And the odds are that that's not going to deliver the performance you need when you recover. So a really important question to look at from a budgeting standpoint is, do I need 100% of my performance? Or can I get away with maybe serving my biggest customer on day one and then bringing all my other customers back or my users back a couple days later when I get additional equipment? Some people are suffering the opposite, where they've really overcompensated and they've put a complete identical environment into their DR site that's sitting in a colo doing nothing for the most part and just being ready. So that's a huge amount of wasted expense and wasted resources that are out there in your environment, basically doing nothing. So we use this chart to sort of illustrate what those points are. And it's fairly easy to look at your own environment and say, man, I'm really over here in the red. I've really overspent, and it's not by that little pie slice there. It's like a big number because I have a really big environment. I put, $1 million worth of equipment into a colo that's doing nothing. And others of you that are on that 5-year depreciation cycle are like, yeah, I've got basically free equipment, but there's no way it's going to run my app. I mean, my app has changed a lot in the last 5 years, and there's no way equipment that I ran it on 5 years ago is going to work. One thing to think about, too, is how does that compare to cloud? So there are two costs primarily in a cloud-based environment. There is your ongoing monthly replication fee. So that's think about, I would call it protection fee, but I think that's what the mafia charged store owners back in the day. So that probably doesn't set up the exact right feel and tone for what it is. But that's really, at the end of the day, that's what it is. You're paying for replicating the data and storing the data in the cloud environment. And the components of cost, and I'm showing you these because I'm actually going to drive that into numbers here in just a minute, is the replication service fee. That basically is a fee you pay for the number of applications or VMs to the provider that you have committed to them. There's a storage cost, which is a cost per gig. So if you're storing 6 terabytes worth of data in your environment, you need to pay to store 6 terabytes of data in the DR environment. That makes total sense. The data transfer cost is, we see on average around 3 to 7% of your data changes every day. So if you had a terabyte that you were protecting, 30 to 70 gigs of that data are actually going to get replicated as they change, as people upload new PowerPoints, upload new data into the database, do software patches, is actually going to get replicated out to the cloud environment. So there's a cost for that. And then if you want resources above your commit level that you want guaranteed, this is almost like if you look from the insurance industry, you might pay for an additional $1 million worth of medical coverage in your car insurance policy just in case someone is severely injured. Or if you don't think the risk is that bad and you've got 6 airbags in your car, et cetera, so on, you might actually opt for maybe more like $200,000. But it's really up to you how much over protection you want in terms of guaranteed resources. And then when you go to recover, that CPU and memory, basically all the cloud resources that you need are added on demand. So you have to cover the cost for those. And then how much additional network access do you need? So to replicate your data, you may have only needed a 10 megabit connection in the cloud environment, but you may require 150 megs of data and network access to run the application for real. So that gets turned on when you declare. So that bandwidth difference can become really important. But again, those only apply when you're in the actual crisis itself. So usually people are more than willing to pay fair prices for resources that they're using when there's a problem. So how does that play out? These are the 3 scenarios that we came up with. We basically have a single application. This assumes you've got a handful of virtual machines that make up that application. This is kind of the getting started model. We left the 4-hour RTO just as sort of a reasonable recovery time out there in a 30-minute RPO. And then we're assuming that for the single application, it's 1 application, but as you see in the other scenarios, we've increased it to 8 applications and then 35 applications, which for a lot of environments, that could be their whole data center environment. We're assuming that you do 2 tests per year. In BlueLock's case, we actually provide that testing for free if you schedule it, which you can do inside the portal itself, or you can call us. But for other cloud providers you might work with, they actually charge you for those. So it's something to definitely think about when you do your budgeting. And then just a little more specifics here, that 1 production application, single application environment, these are the components that we have to protect. So we put about 2 terabytes of storage in there, 5 megs of bandwidth. That's the replication bandwidth, so about 5 megs of bandwidth to move the changes back and forth from production to the cloud every day. 2 public IP addresses, it could be 4, 6, 8. The cost isn't that different. Assuming that might be 10 virtual machines, it could be 5, it could be 7. could be 12, but somewhere in that ballpark. And that at recovery, you'd need to add 20 CPUs and 40 gigs of memory to basically fully build out that particular application. And then as we went through the other scenarios, let's say it's a set of applications, everything that's tier 1, we kind of took the storage up, we doubled it, we went from 10 to 50 virtual machines, 20 to 100 CPU, 5 times the memory at recovery. So hopefully you're sort of understanding how this works. Transforming your whole business, now maybe we're protecting 25 terabytes of data, 75 megs of bandwidth to do all the replication every day, 2.5 terabytes of memory are provided to you at recovery when you actually have a disaster, et cetera, so on, 250 VMs. Price-wise, and again, these are budgetary, but that is roughly what the monthly cost would be to protect those kinds of environments. And, if you cut the storage and the RAM in half, then it has a pretty significant impact on price. But in general, those numbers work out. If anybody has any questions about what might affect those one way or the other, I'm happy to answer those at the end if you type them in the chat window. So other things to consider that we'll walk through as we wrap up here are timing, the amount of testing, the quantity of testing, the type of testing you want to do, the impact of the replication on your bandwidth cost and your network cost, and how maybe other things on your network might impact your RPO time. And then the service-based approach, which is basically, kind of helping you wherever you are on your journey to cloud. So as I was talking about before, timing is really important in terms of what type of thing you're protecting yourself from. So if you know that hurricane season starts in the first quarter, or maybe the highest risk for you is then, the idea that you're, getting this implemented in Q4 is pretty important. We're seeing that it takes about 6 to 8 weeks to get the solution up and running. There's a lot of rumors out there that, you can swipe a credit card and have cloud resources immediately. That's entirely true. In most cases, a lot of you are dealing with a lot more going on than that. There's planning, change management, change control, security, testing, all that good stuff that, a mature IT organization does in addition to just provisioning a server. So if you factor all that in, that takes about 4 weeks to get done in our experience, and then we actually do the first recovery test with our clients to make sure that it's actually going to work, and that takes a little bit more time. If we find anything that didn't work, we make all the changes and make sure that we test it again and it works the next time around. So if you're thinking about it from that standpoint, that's a good time to start ahead of when the issue might arise that affects you. It's also important to note that assumes you've gotten, approval for funding by then, and that can take some time as well. In terms of testing, there are 2 models that we see that think about budgeting for. The real key is how many tests are you going to do, and to what degree do you need the provider to be involved with the testing. So we offer both self-service testing as well as guided testing. And the difference there is we have a self-service portal that you can use, and if you want to test your application on Friday night just to make sure it works because you saw a bad weather report on the weekend, you can test it, make sure it works, turn it off, and go on about your weekend. And we never need to know that you were even in the environment. We'll get alerts and things that you're consuming resources, but you don't have to schedule that ahead of time with us. We also have guided testing, which is where we can actually participate in those tests with you. There's a little bit of a service fee for that, just to compensate the experts that we have involved in the process to help you. And we're seeing that as more popular with organizations that either have less experience with cloud or DR, and they want us to run through it with them, the first time around, so that sort of they can get use that experience as a training exercise, a little more hand-holding than anything. But we also have business units that don't have a strong IT function or want to spend their IT resources on something else and just see and our services, our people on our team as an extension of their team, and they just move forward that way. As I mentioned before, we are trying to reward what we believe is good behavior. We believe testing is really critical. We provide those tests 2 times a year for you. We actually credit you back into the resources you use in the environment. We also provide a sandbox environment. That means you can test the application without any access to the real world. And depending on the type of application, that can be important to isolate it so you don't accidentally disrupt production when you test DR. We have other companies that actually fail the whole thing over for real, and they redirect all the users to the other site. Cost-wise, I mentioned a little bit earlier that the network, when you go to any cloud-based service, because that traffic's going over the network, has a pretty big impact. DR particularly so because of the amount of data that you're moving to keep your environment replicated. So I equate that, I moved past the slide a little too quick. I look at the modern network struggling under the weight of all these cloud-based services as kind of like a bouncy house, where you're kind of all these applications are bouncing up and down together, and some of them are hitting the roof, some of them are bouncing into each other and causing disruption. I suppose you could have an analog for all the little balls that are flying around in there. Maybe that's hackers, but anyway, it's really a disruptive thing on the network. And if we play that out a little bit here, and you look at the internet today versus the internet tomorrow, and you look at Dropbox syncing, Salesforce access, let's say you're backing up to the cloud using Mozy or something like that. Office 365 has to deliver a consistent user experience. All that stuff's fighting on your network. And I mentioned the TWE-Link product. What it does is it really takes the cap off your network today. If you're on a 10 gig cap, you go to 100. If you're on 10 meg cap, you go to 100 megs. If you're on 100 meg, you go to a gig. If you're on gig, you go to 10 gig. And then you only pay for the traffic that you actually flow. So you're not really paying for this horribly overcommitted resource. And we look at that more as a trampoline, where, or if you guys have a Skyzone in your particular city that you live in, Skyzone is a place where you can imagine 50 trampolines all stitched together. Everybody gets their own, and the ceiling's about 80 feet high. So it's kind of the analog for the modern network. I don't know how much this impacts cost. To some degree, I suppose it does. But, are you looking for a high-touch experience, low-touch, where you just consume resources? We talked about that a little bit before. Is this something you want your team to do? Or are you going to take this in-house and build an expertise? What we see a lot with larger IT organizations or more mature ones is that they need our expertise for the first 90 to 120 days so we can bring them up to speed, but then that cost kind of goes away, et cetera, so on. So the services we provide, and again, these are important from a funding standpoint, is we can actually help you with the assessment and planning. So if you're not sure which applications to protect first, or you're not sure if your primary application is connected to 3 other services and it might be complex, we can help you figure that out. In terms of the run books, you're familiar with how the application runs in production, but when you would actually declare it in a disaster, who's going to do what, who's going to call who's going to change the DNS names, all that kind of stuff. We can help you build out those run books and then operate some portions of that for you. And then, of course, the implementation service to get the environment replicated, up and running, and tested. So that is all I have. Alicia,